Hello and Assalamu alaikum guys. In this particular video, we will be discussing two laws of Newton, Newton's first law and Newton's second law. The first law states that an object at rest would remain at rest, or an object moving would continue to move with constant velocity unless acted upon by a resultant or unbalanced force. So the first part of the law is quite easy to understand. So if I have an object resting on any surface, it will keep on resting on that surface unless I would exert some sort of unbalanced force. If there is no unbalanced force, it will keep on resting that way. But the second part of the law, which is a little slightly difficult to comprehend, is when an object is moving with a particular velocity v, then it will continue to move with that constant velocity as well. If there is no unbalanced force, if there is no resultant force, then it will also, if it's initially moving, then it will continue to move with that same constant velocity. So if it has a forward force of 10 Newton acting on it, and it has a backward frictional force of 10 Newton as well, then in that case, it will continue to move with that same constant velocity. Or let's say if an object's falling down and let's say its weight is, let's say 10 Newton, experiences an air resistance of 10 Newton as well. And if it's falling down, so since both forces are equal, it is in the state of equilibrium. The forces are balanced, Newton's first law is applicable, and it will keep on moving with the same constant velocity. In this case, you call that constant velocity also as terminal velocity. So if an object is either at rest or it is moving with constant velocity, it is also said to be in equilibrium. And hence, equilibrium has two types: static equilibrium, when it is resting, or dynamic equilibrium, when it is moving with constant velocity. This first law of Newton is also called law of inertia. Inertia is a property that is associated with mass. So if object has a greater mass, it has a greater inertia, that means it is harder to move that object and also is harder to make that object stop moving. If an object is in equilibrium, Newton's first law is applicable to it, then forces must be balanced. The up force must be equal to down force. The right force must be equal to left force. So if it's moving with constant velocity and you have a forward force of 12 Newton, so you would know that frictional force must also be 12 Newton. Similarly, these vertical forces must be balanced as well. So if it has a weight of 20 Newton, then the normal reaction exerted by the surface must also be 20 Newton. Newton's first law is when an object is not accelerating or it is moving with constant velocity. For Newton's second law, if there is a net resultant force, then the object starts accelerating and its acceleration is directly proportional to the resultant force on an object. And when you remove the proportionality sign, you get a constant proportionality, which is m. Hence, the mathematical form of Newton's second law is resultant force is equal to the product of mass and acceleration. So you have two situations. If an object is either at rest or moving with constant velocity, Newton's first law would be applicable onto it, and forces must be balanced. Whereas if an object is moving with constant acceleration, then Newton's second law must be applicable to it, and you would say that resultant force is equal to product of mass and acceleration. If resultant force on an object acts in the direction of motion, then the object would accelerate. Whereas if resultant force acts opposite to the direction of motion, then object would decelerate. Which means if I have an object moving with a velocity of 10 meters per second and has a backward force of 5 Newton. So if I exert a forward force of 5 Newton as well, then in that case, Newton's first law would be applicable and will keep on moving with the same velocity. Whereas if the forward force is 8 Newton then it would be accelerating because forward force is more. If forward force is 2 Newton, then it would be decelerating because the backward force is more. So if the backward force is larger or resultant force is opposite to the direction of motion, it will decelerate. If resultant force is in the direction of motion, it will accelerate. So let's say if the forward force is 8 Newton, then you have to make note that F stands for resultant force, which means that the resultant force is going to be 8 minus 5, and whatever is the mass of the object, let's say mass of the object is given to you as 2 kg, so you put 2 times A and you'd be able to get the acceleration as 3 upon 2 or 1.5. Whereas, if let's say the forward force is 3 Newton, then the resultant force would be 3 minus 5. This is a negative resultant force because it is the resultant force acts opposite to the direction of motion, equals mass times acceleration. You put 2 times A and you get the acceleration as negative 1 meters per second square. Negative 1 means it's decelerating. So the idea is that any force that acts in the direction of motion would be considered as positive, and any force that acts opposite to the direction of motion is going to be considered as negative while applying Newton's second law. Let's have a look at a few questions. Like, for example, if you look at this MCQ, it says, a person just supports a 20 kg suspended from a rope. What is the resulting force? So I know it's suspended, so it's not going up, it's not going down. So that means that the forces are balanced. The downward force is 200 Newton. So that means the upward force must also be 200 Newton. And hence the answer to this question is going to be D. Let's have a look at some of the practice questions. It says a car of mass 600 kg is moving forward on a straight horizontal road with a constant velocity when engine produces a force of 1200 Newton. Since it is moving with constant velocity, the forces must be balanced. So if the engine produces 1200 Newton force, so that means the backward resistive forces must also be equal to 1200 Newton. This is something I figured out by applying Newton's first law. Then it says find the acceleration when car's engine increases the force to 2000. So that means the forward force is increased to 2000, the backward force we figured out as 1200 Newton. Resultant force would be 2000 minus 1200, that is 800, equals mass times acceleration, and that will get me the value of acceleration here. Similarly, look at question number 2. It says a block of mass 20 kg starts moving on a rough horizontal surface with an acceleration of 0.2. Frictional force is 20 Newton. Calculate the force pushing the block. So the resultant force must be F minus 20, and that's equal to mass times acceleration. You rearrange it and you will get yourself the forward force required, which is coming out to be 24 Newton. In another question, it says a block of mass 5 kg is pulled on a rough horizontal surface by a force of 30 Newton. The frictional force is 5 Newton. We have to find out the acceleration. So forward force is 30, backward force is 5, resultant force is 25, equals mass times acceleration, and I would be able to determine the acceleration here. In the next question, it says a cyclist is cycling on a rough horizontal track. He produces a forward push of 50 Newton, which causes him to accelerate at 0.5 meters per second square. The combined mass of the cyclist and the cyclist is 70 kg. What is the frictional force? So you could be like given a question where there is a particular unknown. You still apply Newton's second law. You say 50 minus F is the resultant force equals mass times acceleration. And you'd be able to get yourself, rearranging it, you'd be able to get yourself the frictional force. In another question, it says the driver of a van sees a red light. He applies brakes. Backward force produced by the brakes is 200 Newton and the frictional force is 150. So both of them should be backward forces, 200 by the brakes and then there's a resistive force. And since he's applied brakes, obviously the engine is not working in the forward direction. So both forces are opposite to the motion. They are both going to be considered negative, equals mass times acceleration. You get a negative value of acceleration, which indicates that the man is decelerating or slowing down. The next question says a toy car of mass 2 kg is moving forward and the motor of the car produces a force of 10 Newton and the backward frictional force is 15 Newton, and we have to calculate the deceleration of the car. So forward force minus backward force would be 10 minus 15 equals mass times acceleration, and you'll get the acceleration getting in negative, which again is telling us that the car is decelerating. The next question says a spaceship whose mass is 1000 kg is landing on some particular planet. The gravitational field strength is 3 Newton per kg and the air resistance over there is 900 Newton. Calculate the weight of the spaceship. So we know weight is equal to mass times gravitational field strength. That will be 1000 times 3 becomes 3000. The resultant force on the spaceship. So if the weight is 3000, the air resistance is 900, 3000 minus 900 gives you the resultant force. And then the acceleration. So Newton's second law, resultant force is m times a. In previous part, we found the resultant force. Mass is given to us. We can calculate the acceleration of the spaceship. So guys, let's have a look at some of the past paper questions and some MCQs. It says when a block of wood of mass 2 kg is pushed along a horizontal flat surface, the frictional force is 4 Newton. When it's being pushed by a force of 10 Newton, it moves with a constant. So obviously, if the friction force is 4 Newton and the forward force is 10 Newton, so resultant force must be 10 minus 4 equals mass times acceleration 2a. So 6 equals 2a, so that means there must be a constant acceleration of 3 meters per second square. My answer is going to be C. And the next question says an aircraft flying at a constant height is gaining speed. It's accelerating. So if it's flying at a constant height, then vertical forces must be balanced. So L must be equal to W, but since it is accelerating, so forward force must be larger than the backward force to produce an overall resultant force. So T must be greater than R, L must be equal to W, and that is in option C. In another question, it says a force of 20 Newton pushes an object of mass 5 kg along a rough horizontal surface where the frictional force is 5 Newton. What is the acceleration? So 20 minus 5 is the resultant force equals 5 times A. 15 equals 5A. That's Newton's second law. Gets me acceleration as 3 meters per second square. If you found this video informative, please subscribe to my channel and like this video.